Okay. Right. Let's get the show on the road. Okay, guys, so welcome. We are grade 12s is hopefully we have grade 12s here in the house, in the building, because we're going to have a live lesson for grade 12s. And we are basically still busy with what? Sequence and series. That's what we've been busy with, guys. So we are going to take it one little bit of a step at a time. Welcome to everyone. I hope you guys can double tap on the screen. Let's get the live, at least let's get our milestones achieved. 1K likes, 2K likes, and so it goes. All right, so let's look at, we're gonna jump in straight today. All right, hopefully we can utilize all the time that we have available, and we can actually make sure that we are covering a lot. All right, which grade? It's grade 12. We are doing the concluding session of sequence and series today. So if we look at this question here, it says calculate. Right, this is basically picking up where I left off yesterday. It says calculate 2 plus 6 plus 18 plus 54 plus, and then there's like this myriad of dots, and then we have plus 4,374. So what does this say to you guys? It says to you, first and foremost, what do we have here? What do we call this? Let's see if people know their stuff. What do we refer to this as? I'm gonna give you guys a chance to let me know in the comment section. What do we refer this as? What is this? 2 plus 6 plus 18 plus 54 plus ... plus 4,374, because we are supposed to calculate this. That's all that this question is saying. We haven't been told anything else. So what is this, my beloved grade 12s? What do we refer to this as? What is it? Okay, Noping, it is indeed a series. Why do we refer to it as a series, Noping? Okay, because you didn't say it's a sequence, you said it's a series. All right, and it's important that you have made that important identification. But the question then is, since you said it's a series, why do you say it's a series? Why didn't you say it's a sequence? What sticks out as a way of identification of a series, of it being a series? Okay, Pills Door, I see what you said there. Okay, thank you, Evile. There is a plus. All right, yesterday, I think it was Miss Zim, when I was trying to explain the difference between a sequence and a series, Miss Zim then indicated yesterday that a series will have terms separated by either a plus or a minus sign. All right, remember, sometimes if it's not a plus sign that's there, sometimes depending on the value of the term, sometimes because it's a negative, it means that positive, and that negative basically makes it a negative sign. So you'll have a plus minus plus minus plus minus, or you'll have a positive sign that is separating the terms. Okay, So thank you so much for that identification. Second question, what type of series is this? What type of series is this? Thank you, Nopingi, for your comment, and thank you, Ivile, as well, for your invaluable comment. You guys are giving very valuable comments. So now the next question that I'm asking now is, what type of series is it? Phoebe Grace says geometric with a question mark. Ivila says geometric series with no question mark. So Phoebe Grace, what I want you to do, no, Pinky says geometric. Phoebe Grace, I want you to change that question mark to an exclamation mark to indicate that you are not saying it whilst still doubting or questioning that it might be something else, but you are sure. Because we must be sure. We can't be iffy, wishy-washy. Now, at this point, because you've learned the concept, you should be able to say it's geometric. Thank you so much, Phoebe. So it is geometric. Why do we say it's geometric? Why do we say it's geometric? Because Ivila says it's because we multiply by 3. What is that 3? What do we refer to that 3 as? Okay, Nopingi says our ratio. Ivila says the ratio. So yes, we have a constant, or what we refer to as a common ratio. All right. Okay, thank you so much for that. Yeah, so that's what we do. So what we want then is to calculate the what then, guys? The sum of what? Of this geometric series. Why do we know for sure that it is the sum of the geometric series? Because we are given all the terms in the series, including the last term in the series. So we know from where the series starts and we know where it ends. So therefore it means we have to calculate the sum of this geometric series. If we already know it's a geometric series and we know what the ratio is, what formula do we use when we are calculating the geometric series sum? All right. And furthermore, how will we know how many terms this series actually contains? Because remember, more than anything else, we need to know how many terms the series contains. This is for 7 marks, by the way. And remember, we have a formula, but we need A, we need R, and we need N in order to calculate the sum of this series. I think as far as A, okay, you use the last term to find how many terms, but first find the formula. Okay, thank you so much, Snenhlanhla Mazibuko. Snenhlanhla Mazibuko has got some understanding there. Okay, all right, thank you so much, Snenhlanhla. We will use the last value, Tn. Thank you so much. You guys are, yeah, you definitely know what you guys are doing. So first and foremost, all right, obviously we A, R, okay, and then of course N. What is A? A is the first term. What is the value of the first term? Okay, I'm really taking things slow today, guys. Yes, 7 marks. Very true, because we need N first. Okay, A is 2, because A is the first term. What is the value of R? Okay, you guys already told me what R is. Okay, 3, T2 divided by T1, which is 6 divided by 2. That gives us 3. N, we are going to have to first figure out what the value of N is. Okay, so remember, guys, that as we have been told by those in the comment section, to find N, we are going to use Tn is equal to AR to the power n minus 1. We are going to use the Tn formula. And what we're going to do is we're going to first find what the nth term is, because A is 2, our R value is 3, all raised to the power n minus 1. So that is Tn. And after that, we take Tn, we equate it to 4,374. Why do we equate it to 4,374? Why? It's because we know that 4,374 is the last term in our what? In our series. So if we can find what is the position of that last term. Remember, Tn is 2 times 3 to the power n minus 1 equal to 4,374. If we can find the value of n, of course, that will mean we will know that if, for instance, we find out this is the 50th term, then it means in total, how many terms do we have? It would mean we have 50 terms. If we find out that n is 17, because remember that n will indicate the position of the last term. And if we find out, for instance, that n is equal to 12, that means that the number of terms we have here is 12. Okay, so all I'm saying is that whenever we want to find the position of the last term, we equate Tn. After finding out first what Tn is, we equate that to the last term. Then we solve for n. And you can see, guys, that our n exponent is going to require our knowledge of solving for exponential equations, which is important because we learned that very well in grade 11. So now let's proceed. We have now 2 times 3 to the power n minus 1, which is equal to 4,374. And what do we want to do? We want to solve for n. So if we look at the relationship between the bases, I'm sure you guys can solve this quite easily, but for the benefit of those that are here and may not particularly know how to do this, we have 2, which is the coefficient of 3 to the power n minus 1. So we are going to divide both sides by what? By 2. So let us do that. And what are we left with after we divide by 2? So I'm going to turn over my page, guys. Right. 2 times 3 to the power n minus 1 is equal to 4,374. Was it? Is that correct? Okay, just want to verify that. Yes. So 2 is the coefficient. So we are going to divide both sides by the 2 to get rid of it. So when we do that, what happens, guys? When we divide both sides by 2, we are left with 3 to the power n minus 1. What's 4,374 divided by 2? My beautiful, efficient calculator people, or those who have the mental maths capacity to basically give us answers just like that. Bontle, you beautiful thing. No, Pinky, thank you so much. So we have 2,187. Now, guys, I just want to say that, all right, we can now take this 2187, and as per what we've learned in previous grades, we can change this composite base to a prime base using our calculator. Or if we don't want to go that route, we also have been exposed to solving an equation in an alternative way. But let us explore if whether 2187 equal to shift and fact, what does it actually give us? Wow, we get 3 to the power 7. Let me just review what I did there. 2187. We press the equal sign. We then press shift. Then we press fact. And then we get the prime base exponential form of 2187, which is 3 to the power 7. So then we can go there now and write 3 to the power n minus 1 is equal to 3 to the power 7. Then when bases are the same on either side of the equal sign, what is the rule for exponential equations? Okay, you'll remember very well that the rule says if a to the power x is equal to a to the power y, then x is equal to y. So if bases are the same on either side of the equal sign, we drop the base, we equate the exponent. So x is equal to y as long as the bases are the same. Then we say n minus 1 is equal to 7. Why? Because the bases are the same. All right. Then we solve for n. This is a linear equation. We take our negative 1, we transpose it. It becomes what on the other side? Definitely positive 1. Thank you so much, Wontle. Such a joy. Then n is equal to 8. So we now know that because the position of 4374 is 8, in other words, this 4374 is the 8th term. As the last term, it's the 8th term. It means how many terms do I have in total since this is the last term? It means that the number of terms that are there or are supposed to be here, including the ones that have not been written down, in total gives me the number of terms that are 8 terms. I have 8 terms in total, guys. So that means because my n is 8, I now know that the number of terms, I have 8 terms in total. Now, I think now we can proceed and find the value of the sum of the number of terms, the sum of 8 terms. So let's recap again. Our a value was 2, right? Our r value is 3. Our n value is 8. The formula that we use to calculate the sum when the geometric series has a value of r that is greater than what? Is which formula? When r is greater than what, do we use that formula? All right, that's very important because we need not forget that. So because this is a geometric series, the formula we use is sum of the first n terms is equal to what? Our r value, guys, is positive 3. R is greater than 1. No, r is greater than 1. So when r is greater than 1, we established that we use this formula. A, thank you, Sekhamete, for the hot me, really appreciate it. A into r to the power n minus 1 over r minus 1. That's what we established we use when r is greater than 1. If r was less than 1, there is another formula for the sum of n terms in a geometric series whereby 1 is first minus r to the power n over 1 minus r. That one we use when r is what? Is less than 1. But when r is greater than 1, we use this particular formula. All we do now is simply substitute. The sum of the first 8 terms is equal to a is 2, r is 3 to the power what? 8 minus 1 over what? Over 3 minus 1. You then grab your calculator, guys. As straightforward and as simple as that is, you grab your calculator, you punch in the fraction 2 at the top. Okay, brackets, you take the 3 to the power 8. All right, then make sure that you drop the cursor, minus 1, you close the bracket, and then at the bottom it's 3 minus 1. Then you say equal. Then your calculator will give you the final answer, which is the sum of the first 8 terms in that geometric series, which is, guys, I'm sure you also saw the sum of the first 8 terms is 6,560, and that's that. So that is as straightforward as we actually go about finding the sum of the first 8 terms in what was not initially clear as to whether we were supposed to find the sum of the first 8 terms. Why? If we go back, guys, and relook at the question, what was the question? The question simply said, calculate 2 plus 6 plus 18 plus 54 plus ... plus the last term was 4,374. For how many marks? For 7 marks. So what we saw first and foremost is, okay, we asked ourselves, what is this? Because they just want us to calculate it. Guys, the word calculate does not mean use a calculator. The word calculate means you need to show step by step how to find the sum of this series. Okay, the word calculate means show step by step. The word calculate and determine in mathematics means show step by step how to go about finding the sum of this what? Of this series. Okay, right? So I hope you understand that. So we established in the beginning that this is a series. Then secondly, I asked what type of series, and people then were able to find the value of r and then confirm that it is a geometric series. So just any ordinary type of series, it's a geometric series. Why did we say it's geometric? Because the value of r, guys, okay, consistently is 3. We have a constant ratio. When you take T2 and you divide it by T1, you get 3. You take T3, you divide it by T2, you get 3. You take T4, you divide it by T3, you get 3. So there's a constant ratio. There's no what? Constant difference. Because when you say T2 minus T1, we get 4. 18 minus 6, we don't get the same value. So this is not a arithmetic series. It is a geometric series. Why? Because the value of r is 3. Okay. So we established that a is 2. A is the first term. R, the constant ratio, is 3. Then in our heads we were like, okay, we need, when we are calculating the sum of a series, we need to know how many terms do we have in total. When we look at this series, the one way in which we can be able to find or understand the number of terms we have is if we take the last term in the series and find the position of the last term. Remember, n in Tn means the position of the term. So if we can figure out what number term this is, then by so doing, we'll be able to then know how many terms there are. For instance, if I find out that this is the 50th term, then that will mean that in total there are 50 terms in this series. If I find out that n is equal to 12, in other words, the number of terms, the position of this term is 12, then it means that in total the number of terms, there are 12 terms in the series. So what I did is I took Tn for a geometric series, found what the formula of Tn is by substituting A, which is 2, and substituting R, which is 3. 2 times 3 to the power n minus 1 is the nth term. After so doing, I took the nth term and I equated, or I made it equal to 4,374. Then after doing that, the nth term, which is 2 times 3 to the power n minus 1, I made that equal to 4,374 as has been equated. Then I solved for n using my understanding of exponential equations. After so doing, divided both sides by the coefficient, which is 2. When I did that, that led me to 3 to the power n minus 1, which is equal to 2,187. Then I converted my composite base to a prime base by using my calculator. Took 2,187 equal to shift fact, gives me 3 to the power 7. And then thereafter, thank you so much, Mayo, for the rows. Then thereafter, I dropped the base 3. Why? Because there's a rule that applies for exponential equations. What does the rule say? If the bases on either side of the equal sign of an equation are the same, then all you do is you simply drop the base a and you equate the exponents. X is equal to y. So I did the same thing here. It's base 3, base 3. I dropped base 3 on either side, and I took n minus 1 and made it equal to 7. Then I solved for n. Therefore, n is equal to, took the negative 1 over to the other side, n is equal to 8. Now, because I know what n is, the position of that 4,307 is 74 is 8. It's the 8th term. So what does that mean, since my 8th term is actually 4,374? How many terms in total do I have in my series, since the last term is term 8? How many terms do I have in my series, since my last term is term 8? How many terms do I have in the series, since my last term is term 8? It means that I have a total number of terms, that I have 8 terms. So after that, I took now the updated information. A is equal to 2, I knew that. R is equal to 3, I knew that too. N is equal to 8. This is what I've just found, because the sum of the number of terms is 8. I use this formula specifically because it is used whenever my R value is greater than 1. Substitute A, which is 2, R, which is 3, N, which is 8, and then use my calculator very beautifully, as you saw here, and then I got my answer, 6,560, which is the sum of the first 8 terms for that series. Simple, straightforward, to the point, guys. Okay. All right. I hope we are okay and we are ready to proceed on to the next question. Okay. Trying very hard to sort of like take it a bit slower than I usually take it, right? And I hope that is also helping facilitate sort of like a bit of understanding for even those that may feel that many times I'm very fast. Okay. All right. Okay. In focus. been doing a lot of problems that are sort of like just, so we're going to look at a word problem here, quite wordy, okay, and it goes as follows: a small amphitheater. I don't know if any of you have actually been to or have actually gone to a amphitheater, but let me just try and do this quickly. I hope the amphitheater. Those who know anything about those that like acting, guys, yeah, pulling up some pictures here so that you can sort of like visually picture what an amphitheater is. But there's a stage there, and then there's where people sit. Okay, this is like an amphitheater. It's where people sit, and it's like row by row people sit, and they are able to watch maybe some show that is happening. I think this is kind of like a much more massive amphitheater. You can see there, the seats are there, and then this is the stage. People are able to watch. So, but here they're talking about a small amphitheater. I'm sure you can see, guys, that there are rows. Some amphitheaters have seats, but this one doesn't have seats, as you can see. Okay, yeah, it just depends on the type of amphitheater, but this is that's an example of what an amphitheater is. I just want to see this one here. Yeah, you see, that's an amphitheater. Okay, yeah, I hope you guys get the point. All right, so this thing is saying a small amphitheater has 10 seats in the first row. 10 seats in the first row. So this is basically the 10 seats. This is the first row. Seat 1, seat 2, seat 3, seat 4, seat 5, and so it goes up until the 10th. Okay, so a small amphitheater has 10 seats in the first row. Then look, it has 12 seats in the second row. So this is the first row. Then the second row has 12 seats. Okay? And 14 seats in the third row. So third row will have 14 seats. So this is kind of like a visual that they have on this amphitheater. Okay, now let's read what it says here. As shown basically above, that's basically our amphitheater. Now it's saying the pattern is continued. Okay, this pattern of arrangement of seats is continued. Okay, the question that is being asked, the first one, it's saying write down the number of the last seat in the fourth row. What is it saying? Write down the number of the last seat in the fourth row. Okay, now guys, that would be the first seat in the first row. That seat number 10 would be the last seat in the first row. First seat in the second row, last seat in the second row. First seat in the third row, last seat in the third row. So they are saying here, write down the number of the last seat in the fourth row. So that means that there will be an additional row here, which will basically be the fourth row, and they want us to write down the number of the last seat. So it would be the seat located right in line with these seats. Okay, now this is 10, this is 22, this is 36. All right, okay, and rightfully so, Sekhamed, I see what you are doing there. All right, So yes, Sekhamid, because you can see, and I love what Sekhamid is saying in the comment section. They are saying a small amphitheater has 10 seats, right? In the first row, there's 10 in the first row, 12 in the second row, then they are saying 14 in the third row. So what did we do here? Since they are saying the second row has 12 seats, you add 10, you get 20. You add 12 to the 10, you get 22. 14 seats in the third row, we add 14 to the 22, we get 36. Then of course, this pattern, 10, 12, 14, of course, in the next row, it will be 16. Okay, so I hope you guys can see this pattern, all right, that is basically emerging of the seats in the last row. Okay, but it is formed by the fact that in each row, as it says a small amphitheater has 10 seats, the first 10 seats in the first row, but then 12 seats in the second row. So if you add 12 seats to the 10, that means the very last seat here will be the 22nd seat. All right, so I repeat one more time. There's 10 seats in the first row. Then they are saying 12 seats. So you are from the last seat, which is seat number 10. What do we do when we are forming this last row? I mean the second row. We add 12 more seats. If we're going to add 12 more seats, it means 10 plus the 12 seats will give you 22 seats. All right, that's why we have 22 there. Okay, because this will be your 22nd seat. Then it says further, and 14 seats in the third row. So in the third row, we are going to, from the 22nd seat, add 14 seats, and then that gives us 36 seats in this row. I mean, we're going to add 14 seats to 22, and then we are basically going to get the 36th seat as the last seat in this row. Okay, so if you continue with this constant difference pattern here, 10, 12, 14, it means to get the next row, how many seats are we going to be adding? We are going to be adding 16 seats. Here, remember, we added 14. Here we added 12. 12, 14, 16. So I'm sure you can see that from this last row, there is an evident arithmetic pattern or an arithmetic sequence. This forms, the addition is forming our arithmetic. All right, I hope you can see that. Okay, so write down the number of the last seat in the fourth row. If we're going to add 16, then it means the last seat will be what, guys? It will be the 52nd seat. Okay, because we are going to say 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, and lastly, the last seat in this fourth row will be seat number 52. Okay, so write down the number of the last seat. Here they're just saying write down the number of the last seat in the fourth row. It is definitely going to be 52. It's going to be seat number 52. Okay, now before I proceed, is anyone having a particular question or lost about something? So once again, I'm saying a small amphitheater has 10 seats. These are the 10 seats, guys, from 1 all the way to 10. Then they are saying in the first row, you have those 10 seats. 12 seats in the second row. So that means if we are going to have 12 seats in the second row, we are continuing from seat number 10, 11, all the way to what? To 22. Because if you add 12 more seats to the 10 that you had, you are going to have your 22nd seat as being the last seat in the second row. Then if you continue to add 14 seats so that you can form the third row, that means the last seat in the third row is going to be seat number 36. Why? Because 22 plus 14 gives you 36. Then remember, this is a linear sequence, 12, 14, 16, all right? So that means you are going to add 16 seats to form the fourth row. If you add the 16 seats to form the fourth row, it means your last seat in this row will be seat number 52. So that's how we get 52 as being the what? Write down the number of the last seat in the fourth row. It is seat number 52. Okay, all right. So I'm gonna just for a moment stop here and see if we are okay. Okay, guys, this is 1 mark. They are saying write down. All right, so you don't want, I mean, you don't want this. This is basically a logical question. All right, and because it's just 1 single mark, there would be no need to be using a particular formula, because you see the question is specifically saying write down. They are not saying calculate or anything of that sort. They are saying write down the number of the last seat in the fourth row. So there has to be some sort of like level of common sense and logical application. That's all. All right, so yeah, just logic here. That it's just logic. Yeah, because this is the same, because if you guys think about it, this sequence 10, 22, 36, 52 is actually a sequence that, if you actually look at it closely, is forming what we call a quadratic sequence. 10, 22, 36, 52. Because what is happening here, our first difference is a arithmetic sequence. Our first difference is arithmetic, which would mean that there's a second constant difference for this particular what? This particular last these terms, 10, 22, 36, 52. All right, I hope you understand that. So logically, if you want to find the next how many seats are in the next row, you are going to add the constant difference and then you are going to add that first difference and then find the number of seats. So this is what I'm saying. At the end of the day, it goes back to just logical common sense as far as it applies to our constant difference. Okay. Knights Beta, yeah, I think you are sort of kind of interfering, to be honest. Interference. How can you find the value of x when it's cancelling out? That's the question that I have for you, but I feel like I don't have much time for such. Okay, next question. Write down the number of the last seat in the nth row. The what? The number of the last seat in the nth row. So what are they wanting, in other words? They want the nth term in this row. Write down the number of the last seat in the nth row. Okay. So there's a row called the nth row, and they want what? The number of that last seat in the nth row. Okay. So we are going to then take 10, 22, 36, and 52 and find Tn of this sequence. So as I said to you here, guys, We are dealing with what type of sequence here? As I said, we are dealing with a quadratic sequence. How do I know that, guys? The reason why I know that is because I could see that the first difference here, 12, 14, 16, in and of itself is a giveaway to me. 12, 14, 16. That means I have a second constant difference. 14 minus 12 is 2. 16 minus 14 is 2. All right. So here I want to find the nth term of this sequence. That's what they are asking for here. Write down the number of the last seat in the what? In the nth row. Okay. Like for instance, we've been writing the number of the last seat in the second row, number of the last seat in the third row, number of the last seat in the fourth row. Now they are asking us to write down the number of the what? Of the last seat still, but in the nth row. So that's why I'm saying that would be Tn, the nth term. Okay. So let's go and find out what that Tn is. So you guys should then know how to find the nth term for a quadratic sequence. That shouldn't be too much to ask from all of you. Thank you, Sekhamitze, for the "you're awesomes." Really appreciate it. Okay, shouldn't be too bad there. You can find most Tn. Okay, you guys tell me, how do I proceed? What do I do next? Come on, in you I trust, my beloved grade 12s. How do I find Tn of this US? We know most. This helps a lot. Okay. Ritabile, straight to the answer, my dear. So I'm sure you worked it out there very nicely. So please, let's not forget the expressions, guys. We know most that here 2a would be equated to the, thank you so much, 2a would be equated to 2. So let's first find a. Our a, just to confirm Ritabile's answer, a is equal to 1. Very much true. You are 100% correct, Ritabile. The next expression we use, which is supposed to displace the first term in the first difference row, is 3a plus b. Remember, the a we already have is 1. In the place of a, we substitute 1 plus b is equal to 12. And then all we do is we solve for b. B is equal to 9. Okay, I think Ritabile definitely got the answer right there. And then last but not least, our last expression that we use is a plus b plus c, which is supposed to be equated with the first term in the original sequence. So that's a plus b plus the c, which is equal to 10. Okay, a 1, b 9, c we want to find. So we substitute the a, which is the 1 there. We substitute the b, which is the 9. We want c, so we solve for c. Okay, so a plus b plus c is equal to 1. Sorry, did I say a plus b plus c? A plus b plus c is equal to 10. Sorry. Then we solve for that. Guys, c is equal to 10 minus 10, because 1 plus 9 is 10. C is equal to 0. So the nth term, so in other words, the number of the last seat in the nth row, the number of the last seat is actually equal to n squared plus 9n. Remember that c is going to be 0, and really and truly that constant 0, no need to write it right there. So there it is, guys. That's the number of the last seat in the nth row. It's actually going to be n squared plus 9n. Okay, n squared plus 9n. And 1, it can be a is equal to 0. A is equal to 1, because remember 2a is equal to 2. You divide both sides by the coefficient. The coefficient of 2a is 2. So you divide by 2 here, divide by 2 there, and that means a is equal to 1. So in the place of a, we have 1n squared. Okay, but that 1 is a silent 1. It's like God, forever present, but unseeable. And just because we don't see him with the naked eye does not mean he does not exist. He is there, ever present. Okay. Then the last question says, if there are 15 rows, find the total number of seats in the theater. I repeat, if there are 15 rows, find the total number of seats in the theater. I'm going to leave that up to you guys to actually figure out. And then I'll just wait for people to give me their responses and their final answers for what they think should basically be how we go about it. Please type everything and anything that you are thinking should be done with this question. How do we go about answering this? If there are 15 rows, okay, find the total number of seats in the theater. This is grade 12, my pinky is 8. Okay, no problem, Ritabile. Yo, sorry, I'm saying no problem. No problem, Dwani, if that's what you meant. Snetlantlama's Bilgo is like, I am guessing it's 360. Ritabile says Tn is equal to n squared plus 9n. Okay, so I'm guessing that's the answer that was previously given for the previous question. Snetlandla is the only one that has guessed as to what the answer is for the question that I have there. If there are 15 rows, find the total number of seats in the theater. Ivila says, I think it's 360 as well. How did you guys get 360? If I am asked, the both of you, how did you get 360? Maybe enlighten us there. What did you do and why? What did you do and why? Anyone who has the Sibindi to share with us what they did and why they did what they did. It's one thing to Ritabile says T15. Okay, why is it T15? Why specifically do we substitute that 15 in the place of n to get our answer? And do we all agree, guys? Okay, Snetland, I think I'm guessing you were saying 15 squared, not 2 times 15, because 15 squared and 2 times 15 is not the same thing. Ritabile says they wanted the value, not the position. Yeah. Okay. Okay, nice. I get you guys. 100%. Nice, beautiful. Yeah. Because remember, guys, if they say this amphitheater does not actually end with 4 rows, but it ends with, there's a 15th row somewhere. All right. Then that last seat that's here will indicate how many seats we have in the house. That last seat in the 15th row will indicate how many seats we have in the house. So what we want to do is we want to take then the sequence of last seats, which we already formed, 10, 22, 36, 52. We want to take that nth term, substitute there, so that we can find, when substituting the position, which is 15, so that we can find what is the value of the term. That seat that is there on your last, as your last seat in the 15th row, what number seat is it? So it is 300, it is basically the 360th seat. All right, which would therefore mean that in total, the number of seats you have in that theater is 360. Does that make sense? So if there are 15 rows, find the total number of seats in the theater. Yeah. So by finding that last seat, what is the the number of that last seat? The number of that last seat, we are able to actually then conclude about how many seats there are in the theater. Okay. So you guys are 100% correct. I agree with you wholeheartedly. So T15 is equal to 360, which means that is the 360th seat. Therefore, we can conclude that there are 360 seats in the theater, in the amphitheater. Word problem, hey? Yeah. Yeah. All right. Yeah, I think, guys, we are good. We are good. Let's proceed. Here's another question. What are your thoughts, guys? Calculate the Okay, Sekhamete, are you asking another question now? How many seats are the last row? Is that what you're asking? You're asking how many seats are the last row? Or you're asking another question? It's a very good question. So, what do you think? How many seats would be the last row? How many seats would be there? Okay. So that's just food for thought for the learners that are there. But yeah, this is the next question, guys. I wanted us to look at. If you guys have an answer to my dear friend Sekhamet's answer, it'd be beautiful to throw your comments there in the comment section so that our dear friend Sekhamet can actually confirm as to whether answer is legit or not. But the next question says, calculate the value of the following without using a calculator. Without using a calculator. Okay. So there, guys, we have 20, the sigma there. P is equal to 5, brackets P plus 1, the whole thing squared, minus sigma, got a 20 there, P is equal to 5, and then P squared. And they're saying here, calculate the value of the following without using a calculator. No calculator should be used. Okay? No calculator at all. Okay. So it's this minus that. And I think what's nice then also then is to establish what's the sum, what's the number of terms we are dealing with here for this sigma and that sigma. Okay. We know most what we do. This P is equal to 5 indicates the number we substitute as our first term to emerge, and this 20 signifies the number we substitute as our last term, all right, to get our last term. Same thing here, all right. Here we have P plus 1, the whole thing squared, all right, and this is neither, it's not arithmetic, it's not geometric. All right, so P plus 1, the whole thing squared, and we have p squared. So this is like an unconventional expression of the nth term. It's quadratic. In actual fact, both are quadratic, and we do not have a formula for the sum of quadratic terms. So here we need to actually apply a bit of logic, and I think if you were to actually do, an observation that is proper, and then apply the basics that you should be able to actually easily get to answer this question without doing too much. All right, so let's first deal with this sigma. As I said, p is equal to 520 p plus 1, the whole thing squared. So this indicates where we start. So if we were to actually write down our series, 5 plus 1 squared plus 6 plus 1 squared plus 7 plus 1 squared plus, now guys, ... we know that at the end here we are going to have 20 plus 1, the whole thing squared. All right, so that's just something to note there, that for this particular series, all right, at least the first 3 terms we can see. All right, we know almost that it will continue up until the 20 plus 1 squared. So let's just reveal what we have. We have 5 squared plus, sorry, not 5 squared, 6 squared, my bad. 5 plus 1 is 6. We have 6 squared, 7 squared, 8 squared, plus, now obviously we're going to have 9 squared, 10 squared, 11 squared, 12 squared, and so it goes up until 21 squared for this series. So I hope you guys see what emerges from this series. Let's move on to this one. All right, let's move on to this one. Okay, Cassidy, just a moment before your question. Let's check out this one, right? This one we know is actually going to be, as we see as well with this particular one, we are going to have 5 squared, because here we are substituting 5 squared followed by 6 squared followed by 7 squared followed by 8 squared. But you get the point, guys. What is our last? When we substitute our last, that's going to be 20 squared. Okay, so this here is supposed to subtract that there. So let me just for a moment then write this: 6 squared plus 7 squared plus 8 squared plus 21 squared, right? Minus 5 squared plus 6 squared plus 7 squared plus 8 squared plus, of course, up until 20 squared. I'm sure you guys can see what needs to be seen. Remember, this minus sign will be distributed to all these terms. Everything here is going to be negative, right? Are we together? Everything here is going to be negative. Okay. Here, this side, all that is here is positive. All right. Everything here is positive, but everything within this particular bracket is going to be negative, because the negative sign is going to affect everything. Remember, this is minus the sum of all that is there. So if you look at 6 squared, it's going to subtract that 6 squared. 7 squared is going to subtract that 7 squared, because it's going to be negative. All right. Okay, I'm just wanting to kind of reveal this to you. I'm not using a calculator here. Okay, I'm just simply applying some logic. Minus 5 squared, minus 6 squared, minus 7 squared, minus 8 squared, minus all the way dot 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 to minus 20 squared. This 6 squared is going to minus that 6 squared. That 7 squared is going to minus that 1. Everything in between here is going to minus everything else in between here up until negative 20 squared. So what is left behind ultimately here, guys? What do we have left behind? The 6 squared is going to bounce. But here, the only thing in this bracket that will be left behind will be 21 squared. Do we agree that that's the only thing? This is going to bounce. That's going to bounce. That's going to bounce. Everything else here is going to bounce except 21 squared. On this side, the only thing that gets left behind is minus 5 squared. So this is basically what I mean by the fact that here we need to apply just a little bit of logic, because the difference between p plus 1 squared and p squared is just 1. So that is why, for instance, with your terms in your series for this sum, you had 5 plus 1. The only difference is 6 squared, 7 squared, 8 squared up until 21 squared. Yes, Kulegan, there's logical common sense that we apply here. All right, because as we said, this here is not a arithmetic series nth term. It's more of quadratic as well as this as well. It's not arithmetic, it's neither geometric or arithmetic. So our formulas, we are hands off from the formulas in this question, but it's easy to fall into the trap of thinking, well, if you don't observe the expression properly, you may easily fall into a trap. Okay, and find yourself using formulas unnecessarily and then missing the plot. Okay. Yo. Hi guys, that one, it was not my doing. Someone else became a little bit excited, so yeah, but it's times like this that I appreciate, and I'm hoping you guys are appreciating. Oh my goodness, that is so funny. The way that happened was so good, like, yeah. And Sekhamedze just finds a reason to actually send me a "you awesome." I believe you feel that magic trick was awesome, right? Okay, no, that's good. Yeah, guys, you see, in this life we can make things appear and disappear. Oh man, that was AI, by the way. That was AI at its best. Okay, AI at its best. Okay, so I hope we understand then the emergence of the two series that we have. This series, like I said, oh my goodness. And I think Sekhamedze is just eating this one up, because now I think I understand this whole this profile picture of yours, Sekhamedze. I think you did indicate that you're a female, but like now I see your profile picture and I'm like thinking to myself, isn't that like a magician sort of attire in your profile picture? Okay, anyways guys, so from this emerges this series, okay, and then from that, this here emerges the second series. Okay, how many marks is that? You guys love marks, don't you? Love marks. It's like every single time now I have to be ready to give that answer of how many marks. How many marks is it say? Okay, let me just check. It's 4 marks, eh? It's 4 marks. Give 4 marks. All right. Yeah, it's 4 marks because it's an unconventional question, that basically, like I said, the nth term here, or the p term, if you want to call it that, the general term that we have is not geometric or arithmetic, but rather it exhibits another quality, which in this case is quadratic. We don't have a formula that we usually utilize when we're wanting to find the sum of n terms for a quadratic series. So here, as I said, designed in such a way that you can actually write out the terms and then you can actually subtract the prevailing terms that repeat themselves, all right, because of the subtraction sign. Remember, the subtraction sign is distributed to all terms there, then we can subtract and we can write what remains. So that's 121, guys, minus 25, which you guys should be able to give the answer to very easily without necessarily being someone that, would use the calculator from the onset. So you could say here we showed our steps, right? We showed our steps. The series, first and foremost, from the first sigma, then the series that prevails that prevails in the second sigma. Then after that, guys, all we do is we actually subtract, we write what's left over, and then we subtract 121 minus 25, which gives us what, guys? What's 121? No, sorry. 21 squared is not 121. Sorry, guys. Me, I'm thinking it's 11 squared here. What nonsense. 441. My bad. Askisne. Thank you so much for that clarification. Me, I think I'm lost in this magic trick that just happened. I'm sorry about that. Okay, 441 minus 25, guys. Then that should give us a nice answer of 416. Thank you, Ivile. Thank you for that. I guess the AI. Hey, Ritabile, wena. Ritabile, you are hilarious. You are unbelievable. How could you use that against me? How could you? The nerve to use that against me. Can we hear those chunks? Are you serious? Okay, guys, this is basically, this is what I call goodness, eh? Yeah. This was no magic trick. This was legit. This, guys, is super duper legit. Very good, sir. No AI. No, it wasn't AI, it was legit. Okay, let me give that to you guys. Let me give this one to you now. I think let me give you a problem that you can work on your own here. Well done, sir. You are unbelievable. Ish. Yeah, ne? Now people's mouths are watering. Okay, here's a question for you guys that you can do. Let me give you this one to you guys to do. In a geometric series, T6 is equal to 6 over 32. Yesterday we did questions similar to this one, and T2 is equal to 3. They are what, guys? In a geometric series. Now they explicitly are giving us T6 is equal to 6 over 32 and T2 is equal to 3. The series consists of positive terms. Find the first term and the constant ratio. Okay. Right, this is your guys' time to shine. Come on, shine for me. Yo, Cassidy, you are funny. Yo. Yo, you are not for real. Cassidy, where in the world did they get you from? I have a lot of guys, whilst you shine in the mats, me, I shine. Oh my goodness. Guys, that's all. So in a geometric series, T6 is equal to 6 over 32. T2 is equal to 3. The series consists of positive terms. All they want is find the first term and the constant ratio. That's it. That's all they want. The first term and the constant ratio. That's all they want. That's all they want. Well, hopefully you see it now. Okay. We good, we did. Okay. No, Pinky has gotten something there. Can we confirm No Pinky's answer? No Pinky says A is 6 and R is equal to half. Are we... Can we confirm that or disagree? Agree, disagree? Or we agree to disagree, or we disagree to agree? Okay, so if you remember, guys, this particular question, we did similar questions yesterday, where we set up two equations, you know. T6, hopefully we understand if it's a geometric series. Oh, definitely awesome, Cruz. Cruz got the same answer. No Bingy. I love your name, No Pink. Is No Pink your actual name? No Pink Oganye, is it like a nickname? Got the same. Okay, awesome. Okay. T6 is equal to 6 over 32 and T2 is equal to 3. So hopefully, guys, you wrote down term 6 as AR to the power 5. Okay. Ne? Yeah, because it's always, if it's term 6, then obviously the exponent is always 1 less than the value of the position. Okay, it's always 1 less. Then T2, so we have equation 1, have equation 2. Then what do? Divide. We know most we divide. So we are going to say equation 1 divided by equation 2. Okay, A and the A cancel. We are left with R to the power 5 minus 1, guys. The other side, we have 6 over 32 divided by 3, which is the same thing as 6 over 32 times 1 over 3. So R to the power 4. Let's see. 3 goes into 6 how many times in the numerator? 2. So that's 2 over 32. Is that correct? 6 over 32 divided by 3, which means 6 over 32 times 1 over 3. 3 goes into 6 2 times. We have 2 over 32. We take the fourth root there, right on either side. Interesting. Maths in December. Yes, definitely. I was supposed to say 2 divided by 1. Makes no difference. Makes no difference. Makes no difference. I'm unmuted, mostly. Yeah, I'm unmuted. Okay. Yeah, sorry guys, I just had to make sure that I finished the magic trick. So it's complete. Okay, you remember there was things that were full, now they are gone. I just had to complete that magic trick, guys. Okay, now I'm here, available, fully so. Okay, r to the power 4 is equal to 2 over 32. So yes, guys, 6 divided by 6 over 32 times 1 over 3. 3 goes into 6 how many times? Twice, which is what we want. 3 goes into 3 once, 3 goes into 6 twice. So we have 2 over 32 as the answer. Then what do? I mean, I can take the fourth root on both sides so that I can cancel that root. That gives me r. But remember what I do on the left, I do where? On the sweet, amazing right. Okay? Yeah, we say the fourth root of 2 over 32. So let's go to our calculator and actually go and type the fourth root of 2 over 32. We just, where's the, okay, that button, we say shift, we choose that button so that we have a 4 there. Then we come inside, we write 2 over 32. Yes, r is equal to a half. Retabile, you're 100% correct there. It's a half, my dear. R is equal to a half. Okay, simple, straightforward, just like that. Yeah, because mostly you can simplify 2 over 32, it becomes 1 over 16 if you wanted to actually do it in another way, because you know most you can simplify 2 over 32, it's 1 over 16, and then this becomes r to the power 4 is equal to 2 to the power negative 4. Just depends on who wants to do the problem. Then you can raise both sides by the exponent 1 over 4. That gives you r is equal to 2 to the power negative 1, which means r is equal to half. So that's just another way of looking at the same problem. Okay, I just so that you guys know. Yeah, so calculator approach, more exponential, simplifying exponential, changing 1 over 16 to be 2 to the power negative 4, taking the rational reciprocal of 4, which is 1 over 4, and doing that on the right hand side too, and then getting 2 to the power negative 1. You know that a base raised to a negative exponent, that's 1 over 2. Then remember, we want a as well, because what did they ask for? They said they want us to find the first term and the constant ratio. So we have the constant ratio. What we are missing now is the first term. So we can go, let's go there to equation 2, and then say a into 1 over 2 is equal to 3. Okay, then what do we do, guys? If we want to find the value of a, we just multiply both sides by 2. Because this is 1 over 2, we can multiply by 2 over 1 both sides, or we can divide both sides by half. At the end of the day, if we multiply both sides by 2, a is equal to 6. Okay, so that's the constant ratio, and that is the first term. And I think that works out quite nicely and smartly. At the end of the day, we are able to get our answers. All right. Yeah. Thank you, Sekhametsi. Sekhametsi is very kind. It's like Sekhametsi waits for this, you know, for magic tricks to happen, or for answers to emerge, and then voila. Thank you, Sekhametsi. Really appreciate the kindness. It's really appreciated. Thank you. I don't underestimate, nor do I not appreciate the gifts when they come, because I know how scarce they are. So I really appreciate it a lot. Okay, guys, look at this question. This one is very interesting. You got me. Rifitla, what time today? Oh, when are we finishing? Let's take it up until 11:30. Is that fine, Tabile? Rifita, what time? I love it. So is that fine? 11:30. Okay. And that give you enough time to actually go grab your own magic trick. Hopefully that Kisipedi. No, that's fine. I'm really loving the speediness. It's always cool. 12 will be cool. Mzala is like at 12 o'clock. All right, we can push it up until 12. Let's just check. Ritabila, are you fine with 12? I think Ritabila has some plans tonight, if you know what I mean. Interfering with the plans. Okay, awesome. 12. Okay, we'll cut it off at 12, guys. Okay, look at this one. The first term of an arithmetic sequence is what? Is 6. Please take note, guys. The first term is 6 of a what? Of an arithmetic sequence. The first, third, and 12th term of that arithmetic sequence forms the first 3 terms of an geometric sequence. Then the question is saying find the first 3 terms of both sequences. All right. This I'd like to give to you to do as well. All right. I don't have anything that I want to attend to whilst doing that. I just want to see what can you guys do with the given problem. I repeat, the first term of an arithmetic sequence is 6. So that first term is 6, right? The first, third, and 12th term, we are told, of the arithmetic sequence actually form the first 3 terms of a geometric sequence. So the question is then find the first 3 terms of both sequences. Let's go. And yes, 7 good marks. The first term of an arithmetic sequence is 6. Then they move on to say the first, third, and 12th term of the arithmetic sequence actually form the first 3 terms of a geometric sequence. The question is find the first 3 terms of both sequences. How do you move in such a scenario or situation? Mzala, I don't have my pen with me. I'll wait for correction. I wonder where are you that you don't have your pen with you? Do we need to send a search party to go and look for you? Okay, so I'm going to give you guys a chance to attempt the problem because I want you guys to also apply your minds, and to see what you can actually do with the given problem. Yeah. What is your answer, Ritabil? I want to hear your answer. What's your answer? What is this answer that you're not happy with? Please be so kind and share that answer with me. I want to know, what answer did you get? I'm not happy with my answer. What answer did you get? You might not be happy with your answer, but the answer is the answer, my dear. You might not be happy with your answer, but the answer is the answer. And I will tell you this, sometimes people are not happy with their answers because they are not numbers, maybe they are fractions or decimals, and then they're like, this can't be right. Okay? What matters here is that the math is done correctly, and you might just be actually doing the right thing, and the answer is correct. So don't be too hasty to declare that it's not correct or it's not the right answer. So for the first three terms, I got 6, 9, 12, 15. Okay. For the second ones, I got 6, 9, 27 over 2, 81 over 4. But I tried and failed, I see. We listen, we don't judge. No, definitely. Well, thank you for attempting it. That is what's important here. The fact that we attempt. We listened, we did not judge, and we appreciate your attempt at it, Tabi. Okay. Good for you. High five. High five there. Bah. You sense my high five there. Hope you felt it there. It was a good high five. Yep. Mzala is saying D is equal to 3. Yep. Okay. All right. I think at least Mzala is like, I found that too. Okay, so do any one of you two, it seems like you guys got the same answer, Umzala and Ritabile. I'd love to give any one of you two a chance to actually walk us through how you guys did it, so that we can actually see what it is, what knowledge you guys applied. So who out of the two of you is brave enough to Tn is equal to 6 plus Dn minus D. Dn minus D. Or at least first I'll let me have a shot at it, and then we'll compare what you guys did and what I did, and then we will get an opportunity not to just listen but to judge, if that makes any sense. We listen, and sometimes we don't judge, but then we get to a point where we listen and then we judge. So, and then we apply correct judgment, applying correct knowledge. Okay, let's see. So here it says the first term of an arithmetic sequence is 6. So the reality of the matter is that the first term, we know what it is. It's 6 car. No one can cheat you out of the knowledge of the first term being 6. Okay, makes sense? First term of an arithmetic sequence is 6. So the first term of an arithmetic sequence is 6. The first, third, and 12th term of the arithmetic sequence. The what? The first, the third, T3 is A plus 2D, right? Right? But more specifically, it would be 6. Then of course, since we know that A is 6, that means A is 6 plus 2D. I think we would agree with that, right? That the first term is 6, right? The third term, remember T3 is going to be A plus 2D, right? A plus 2D in terms of A and D. Term 1 is A, which is 6. Term 3 is A plus 2D, but can be written as, since we know what A is, that it's 6, we can say 6 plus 2D, right? And the 12th term, guys, is going to be A plus 11D. But of course, we are going to say 6 plus 11D because we know what A is. A is 6, right? That is for the arithmetic sequence. The first, third, and 12th term of the arithmetic sequence, we are told, actually form the first 3 terms of a geometric sequence. These form the first 3 terms of the geometric series. So 6 plus 2D and 6 plus 11D actually form the first 3 terms of a GS. These 3 terms. Currently, I have these terms, term 1, term 3, and term 12, which are actually term 1, term 2, and term 3 of the geometric series. These terms, 6 plus 2D, and 6 plus 11D, are the first 3 terms of a geometric series. Then the question is, find the first 3 terms of both sequences. Find the what? The first 3 terms of both the sequences. Okay. Right? Right. So with this knowledge, this one, these 3 terms that are term 1, term 3, and term 12, which are actually going to be the first 3 terms of the GS. Okay. I think we can grab these terms and we can use them. We can grab these terms and use them under geometric sequence conditions, which means, in other words, that means the following. It means that I can use the fact that these are the first 3 terms of a geometric series. I can say T2 divided by term 1 is going to be equal to T3 divided by term 2. All right, because these three are also the terms, the first three terms of the geometric series. So it means I can say 6 with 6 plus 2d with 6 plus 11d are actually the first three terms of a geometric series. So I'm going to plug them into this formula, guys. Plug them in here. All right, I'm going to plug them in there, and I'm going to solve for I think initially for d, because here I can only solve for d. So what's T2? T2 is 6 plus 2d. Okay, I don't have space here. I don't have space, so let's look for space. So this was 6 plus 2d over 6, which is equal to, what was the third term, which is the 12th term, guys? 6 plus 11d over 6 plus 2d. Then let us go ahead and solve for d. Cross multiply 6 plus 2d into 6 plus 2d, which is equal to 6 into 6 plus 11d. Then let us solve for d. We FOIL. Guys, foiling really now, I think you guys are in the position of foiling. What 6 times 6 is 36. 6 times 2 is 12d. 2d times 6 is another 12d. And lastly, 2d times 2d is 4d squared. On the other side, we have 36 plus 66d. So now we are going to actually transpose and solve for d. 4d squared. 12d plus 12d is 24d. 24d. 24d, you take the 66, you minus, so we have 24d minus 66d. All right. 36 minus 36 will give me 0. So on the other side, we have nothing left. But this is 4d squared minus, this was 24, positive 24, sorry, minus 66. Positive 24 minus 66 gives us negative 42d. Okay. 4 minus 6, negative 42d. Okay, negative 42d. Okay, then we have a highest common factor, which is 2d. We are left on the other side with 21. Then we get two answers. Okay, we get two answers. Remember, 42 divided by 4 is not really, yeah, you know what I mean. Then d is equal to 21 over 2. Two answers, d is equal to 0, and also d is equal to 21 over d. Okay. D is equal to 0 and also 21 over 2. Okay, so if we relook at the sequence that we had 6 plus 2d, right? And we had 6 plus 11D. Remember, for our arithmetic sequence, this was term 1, this was term 3, and this was term number what, guys? Term number 12. For the GS, these are the first 3 terms of our geometric series. So if I take 0, all right, and I say that is the value that I'm going to substitute, all right, that would be 6 and another 6 followed by another 6, okay, which would not make sense in all honesty when it comes to the geometric series. Well, not geometric series, but to the arithmetic series, given that they said what they said about term 12 and all of those things. So we are going to have to take the other value, which is 21 over 2. I think Ritabile, what you want to say is, yeah. So if you said 42 over 4, you simplify that, it's 21 over 2. Okay, hopefully that makes sense. So if you take 21 over 2, all right, because these are the first 3 terms of the geometric, we are going to have the first 3 terms of the geometric, all right, that's going to be straightforward in the substitution. So what are the terms, guys? We have 6 for the geometric sequence, followed by what? Very good, Gabby. Followed by 27. Thank you so much, because 2 and the 2 cancel out. 21 plus 6 is 27, followed by what after that? Okay, just grab your calculator and punch it in. Very good, Ritabile. 243 divided by 2. These are the first 3 terms of the geometric sequence. All right, yeah, these are the first 3 terms of our geometric sequence. Okay, yeah, it's better to just write the answers as fractions, okay, rather than decimals. All right, okay, then what about the arithmetic sequence? What about the arithmetic sequence? How would we write the arithmetic sequence? Okay. Remember, guys, term 1 is 6. Term 2 is going to be A plus D. All right. A plus D. So if we go to the arithmetic sequence, obviously term 1 is 6. Term 2 is going to be A plus D. In other words, 6 plus what? We are going to say 6 plus 11. 21 over 2. 6 plus 21 over 2. Okay, do you see why we say 6 plus 21 over 2? Because the D is 21 over 2. We know term 1 is A, term 2 is A plus D, term 3 is A plus 2D. At least A plus 2D, we know what the third term is going to be. Okay, It's going to be 27. But the second term is a plus d. A is 6 already. 21, 6 plus 21 over 2. That's the answer we want to get. So we have 6 followed by what? 33 over 2, then followed by 27. The question, Sekhamets, was saying what? Find the first 3 terms of the geometric and the arithmetic sequence. Okay, it said the first 3 terms of an arithmetic sequence is 6. The first, the third, and 12th term are actually of the arithmetic sequence. They form the first 3 terms of the geometric sequence. Then it says find the first 3 terms of both sequences. So we wanted the first 3 terms of both sequences. That's basically what we were gaming or gunning for to find. And so ultimately we are able to get there and find that. Okay. Awungeke saneleke during the holidays. Awungeke mengisengiyalela mina phela. Awungeke during the holidays. Ima. I think that's what I'm gonna do now. I'm just gonna mimic all the people that come with these comments. I think that's the best thing. Let me try and get you guys entertained by always doing that with all these people that come with their comments. Oh, during the holidays. Yeah. Okay. Yeah, guys. So that's how we do that problem. You guys. The love I have for my audience that's here. You guys have no idea. It's like you guys are growing on me. I forgot to do this question yesterday. Guys, do you remember the question that I did yesterday, where we were considering the following geometric series, this one, and then we were saying find the value of x for which the series will converge, and we did by first setting up the r is greater than -1 but less than 1, and then finding r in terms of x by taking t2 dividing by t1 and getting r, and then taking that r and substituting it back in the place of r in this compound inequality and solving the compound inequality, which we did successfully. All right, applying our grade 10 knowledge, and we were able to get the value of x for which the series converges. Okay. Oh, you joined when I finished solving that. So, oh, Shem Ritabile yesterday, so you missed that. But nonetheless, yeah, you see the YouTube video. I've uploaded that video that basically was covering that particular part. Okay, because this question had a follow-up question, which is what I actually missed, where it says find the sum to infinity of the series if x is equal to 3. And I guess that's the part I basically wanted to follow up on. But let me just relook at the question so that you guys are on board with what it means when we talk about converging geometric series. The question was saying consider the following geometric series. Okay, here it is, 3 into x minus 1. So the term 1, 2, and 3 are written as a algebraic expression. Okay, 3 into x minus 1 is the first term, plus x minus 1, the whole thing squared, is the second term, plus 1 over 3 into x minus 1 to the power 3 is the third term. So you have the first, second, and third term, which are a series expressed in terms of x. Okay, and they are saying x cannot be 1. Then they say find the value of what? Of x for which the series will converge. Okay. Now, very quickly, I then said to you guys, okay, because the question ends here. How we approach answering the question is we first and foremost ask ourselves, what does it mean when they say a series converges? Guys, if a series converges, it will converge if the value of r, the constant ratio, is greater than -1 but less than 1. So in other words, the value of r must be between -1 and 1 for a series to converge. Okay, so what we do is we use this constant ratio condition, which is r is greater than -1 but less than 1. Okay, we write it out. Then we calculate the value of r. In other words, we find the constant ratio for this given expression. We find that constant ratio in terms of x. So how do I find the constant ratio? Okay, constant ratio, you find it by taking term 2, you divide with term 1, right? Because you are already told here that this is a geometric series. That means your ratio is going to be constant. So you can simply just take term 2, which is x minus 1, the whole thing squared, divide that by what? Term 1, which is 3 into x minus 1. Okay, does that make sense? 3 into x minus 1. Then what we simply then do is we simplify what we have been given there, which is x minus 1, the whole thing squared, over 3 into x minus 1. We simplify that. So we have x minus 1, we have 2 of these x minus 1s. Then in the denominator, we have 1 of this x minus 1. So this x minus 1 and that x minus 1 cancel each other. But remember, you are left with another x minus 1 because you had 2 of them. Here you had 2 of them, here you had 1. So when you cancel, the bottom one obviously leaves. The one at the top remains. The single one, the x minus 1 in the top, remains. So you have x minus 1 in the numerator, and then in the denominator you are left with 3 times 1, which is 3. This is the constant ratio of your geometric series in terms of x. It is x minus 1 over 3. In grade 10, you learned how to simplify these types of algebraic fractions. So this is just a reminder here that this is grade 10 simplification. It is not in any way grade 12 in any shape, form, or fashion. After getting your r value, which is in terms of x, remember you wanted to find the value of x for which the series will converge. It converges. A series is a converging series when r is greater than -1 but less than 1. So you are going to take your beautiful r, which is in terms of x, go and plug in the place of r x minus 1 over 3. Take x minus 1 over 3, go and plug it in, substitute it in the place of r in this inequality. So right over there, this is my constant ratio restrictive formula for when I have a converging series. R is greater than -1 but less than 1. I have now substituted in the place of r the constant ratio x minus 1 over 3. There it is. Then I'm going to go back again to grade 10, solving an inequality, a compound inequality, because in grade 10 we did compound inequalities, how to simplify a compound inequality. The objective is to make sure that I have x alone in the middle and numbers only right and left. So x minus 1 over 3, the first objective is to get rid of 3 in the denominator. X minus 1 is divided by 3. How do we get rid of the 3 in the denominator? We multiply by 3 over 1, which is the inverse or the reciprocal of over 3. We multiply by 3 over 1. But remember, what you do in the middle, you must do on the left and you must do on the right. So the cancellation there is gone. You are left with x minus 1 alone in the middle. Then 3 times negative 1 is negative 3 on the left. 1 times 3 is 3 on the right. The next thing, we need to get rid of negative 1. How do we get rid of negative 1? We use the additive inverse. The opposite of negative 1 is plus 1. So since this is minus 1, we are going to add 1 so that we get rid of this negative 1. But what you do in the middle, you do on the left, you add 1 there too, you do on the right, you add 1 there too. What does that lead you to? X alone in the middle. A number which is negative 2, because negative 3 plus 1 is negative 2, and 3 plus 1 on the right, because 3 plus 1 is 4. Now you have your value of x. What is that value of x? The value of x for which the series will do what? Will converge. What is the value of x? It is when x is greater than negative 2 but less than 4. But remember, in the geometric series there was a restriction that x cannot be 1. X must never be 1. Therefore, in our final answer, we have to say that even though the value of x must be between negative 2 and 4, the value 1 cannot be included in that answer. So we say x cannot be 1 even though x is greater than negative 2 but less than 4. All values between negative 2 and 4 are fine except 1, which is also a value that's there, but we can't have 1 featuring there. So this is how we are able to find the value of x for which the series will converge. Okay, step by step, that's how you move in getting the value of x for which a series will converge. And to me, all I'm doing, I'm simply repeating that question that I answered yesterday just before I ended the live, which was talking about how to find the value of x for which a series will converge. Okay, that's how we go about it. All right, then the follow-up question, which I did not answer yesterday, which I want to answer now, is the question says, find the sum to infinity. Thank you, Sir Hamiz. Find the sum to infinity of the series if x is equal to 3. What are they saying? Find the sum to infinity of the series if x is equal to 3. Now, when they say sum to infinity, they mean the formula sum to infinity is equal to a over 1 minus r. This is the formula we use, which is called the sum to infinity formula. All right, very important formula, this one. Okay, very important formula, this one. Very critical, very, very important formula. Right? So how do we then answer this question? Find the sum to infinity of the series if x is equal to 3. We need a and we need the value of r. From the series that we have, do we have the value of a? Yes, we do. The first term is a, but do we have the numerical value of a? No. So what did they say here? If x is 3, find the sum to infinity of the series. So I'm going to go back to my series and I'm going to substitute in the place of x 3. 3 into 3 minus 1. And I'm going to calculate what the value of a is. What's 3 minus 1? It's 2. So that's 3 times 2, which is 6. So my a value is 6. Take it in. Find the sum to infinity of the series if x is 3. Remember, guys, I had found what will make the series converge. It's when x is between -2 and 4. And it so happens that this x value, which is 3, is a value that is actually in this interval. So it's an acceptable value to make my series converge. It's an acceptable value. When x is 3, the series will still converge, which means you can find the sum to infinity of your series. Right? So we can get a first by substituting 3 in the place of the first term where x is. 3 minus 1 is 2. 3 times the 2 gives us 6, which is the first term. That's a. Now we need r. How are we going to find the value of r? We are going to take the same value of 3 and substitute it there in the place of x, where our constant ratio r is actually located. So we're going to do the same thing and say r is equal to, in the place of x, 3 minus 1 over 3. What's 3 minus 1 in the numerator? 3 minus 1 in the numerator, that gives us 2 over what? Over 3. All right. This value of r, which is 2 over 3, that's not comma 66666. That value is a value that is between -1 and 1. So it is basically really values of x that are between this -2 and 4, which will give us values of r, the constant ratio, that are between -1 and 1. So truly our r value is 2 over 3. For a series that converges, r must be between -1 and 1. This is something you need to really tune into, guys. It wouldn't make sense if when we substituted 3, we got a value of r that was not in this interval, because that would mean the series is not converging. For a series to converge, the value of r must be greater than -1 but less than 1. That's what 2 over 3 shows. It's a value that is between -1 and 1. Now we take the a, we go and substitute. We take the r, we go and substitute. Then we use our calculator, guys, just our calculator, and we plug this in and get the answer. Simple as that. So I'm going to say 6 divided, right? 1 minus 2 over 3. Okay. The answer is 18. That's the sum to infinity, as Ritabile confirms in the comment section the second time now. Okay. So sum to infinity is simply that, guys. Sum to infinity can only be calculated, guys, when r is between negative and 1 and 1, which means, in other words, that a series needs to be converging in order for us to be in the position to calculate the sum to infinity. Listen to what I'm saying there. The value of r must be between negative 1 and 1 for us to calculate the sum to infinity, because the sum to infinity is calculated for geometric series that converge. Okay. Yeah, and if you guys can stick to that, we will be okay. Okay, we will be okay. Okay. Right, let's continue. Thank you, Sekhametsi. Sekhametsi is like really unleashing them gifts. Thank you so much, my sister. I don't want to say my brother again, lest you shambok me again like you did the last time in the live. Calculate. Okay, let's do these two. Sigma. 20 at the top. Obviously, substitution of 20 into the expression means our last term. P is equal to negative 2. Substitution of negative 2 into the expression, that is the value of the first term. Substitution of this means the last term. Substitution of that means the first term. That's something you need to know where sigma is concerned. And obviously, if they say calculate, it means we need to calculate the sum of this entire what? This entire series. What type of series is this? Okay, 7 minus 4p. 7 minus 4p. 7 minus 4p. What type of series? Look at this, guys. Immediately you should be able to know what type of series is this. Geometric or arithmetic? You should know. Ritabile, very good. Arithmetic. Why did you know instinctively that it is arithmetic? Okay. Why did you know instinctively that it is arithmetic? Look at P. Look at the variable. Where is it? It is multiplied to a coefficient. So that speaks of linear. Linear sequence is the same thing as arithmetic. Okay, so take note, guys. Whenever the variable is placed next to and the exponent of the variable is 1, then that means that is a linear. The variable in the numerator placed next to a coefficient or as a single alone term. Okay, whenever this variable you have there is alone, exponent is 1, then it says that it's a linear sequence, and a linear sequence we know is arithmetic. Sorry, not sequence, series. Okay, linear means arithmetic, arithmetic means linear. All right, but if there was a variable p in the exponent, then we know that is geometric, you see. So please take note of these things. The problem we had done earlier on, the variable was also next to a coefficient, but then the variable had an exponent that was 2. Okay, that exponent 2 does not mean linear, it means quadratic. So that's why we were able to see that this one, there's no formula for it, so we need to actually use our logic and our common sense and substitute and simplify. Does that make sense? So Take note, guys, this is actually your general term for the given series. Okay, so the first thing we usually do when we calculating or simplifying, obviously, such, is step one. Let's get the series. Vinny, go December. No. Vinny, I can see Vinny's head. Like, Vinny comes into the live by mistake. He looks at the live screen and he sees the maths happening and he's like, come on guys, I'm still enjoying my time. And when I want to do this maths for December, no. Yeah, Vinny. Hi, Vinny, change your ways, my guy. Change your ways, my guy. Okay, anyways, 20 p is equal to -2 in the here. So this is for substitution for our first our first term. Then 20 is our substitution for the last term. Are we together? So let us go ahead then and substitute to get the terms of the series. So we first substitute -2 to get the first term. 7 minus 4 into -2 plus 7 minus 4, the consecutive value after -2 is -1, plus 7 minus 4, the consecutive after -1 is 0. Okay, we at least need the first 3 terms. So we have 7 plus 8 plus 7 plus 4 plus 7 minus 0. We have 15 plus 11 plus 7. These here, guys, are what we call our first 3 terms in the series. We need those first. That's what we start with. 2, let us figure out the number of terms that we need to be adding, because we are going to find the sum of that particular number of terms. How do we get that? We take the top number here, we subtract the bottom number, which is this one, then we add 1. So in other words, we are going to say 20, there's a minus sign there in the formula, minus -2, because the p here, the value here at the beginning is -2, plus 1, which gives us what, guys? 20 plus 2 plus 1, which is actually equal to what? 23. So our n is going to be 23 for the sum of the number of terms. We are going to calculate the sum of the first 23 terms. Are you with me, guys? Hey, I hope you are feeling me here. This is an arithmetic sequence. The formula number 3 that we are going to be using is either Sn is equal to n over 2 into 2a plus n minus 1d. We can use this formula, or we can use this formula. It's up to us which one we want to use. This one will be used only if we have the value of the last term. And guys, we know that the value of the last term can be found if we take 20 and substitute into the formula. The value of the last term plus ... plus the last term. We take this 7 minus 4 into 20 and we get the value. 7 minus 80 is -73. I repeat. You substitute in the place of p, you substitute 20, because remember, guys, I said to you, substitution of p is equal to -2 gives you your first term in your series. Substitution of 20 in your series gives you the last term in the series. Hi, we are moving now. Hey, we are moving. Walala, wasala, wasala, walala. You know? We are moving now, guys. We are moving. Walala, wasala, wasala, walala. You know what I mean? Hey, I'm telling you the things here. I'm telling you the tellings. All right. So I repeat once again. The 20 at the top is the value we substitute in the nth term so that we get the what? The last term in the what? In the series. The p is equal to -2 is the value that we substitute in the nth term to get the what? The first term in the series. Each subsequent value after -2 that we substitute gives us the next. Okay, we substitute -1, we get the next term in the series. We substitute 0, which follows -1, we get the next term in the series. All right. And of course, the very last term in the series, which is further along, is when we substitute the 20, which is at the top there. 7 minus 4 times 20, which is 7 minus 80, gives us -73. Okay. Are we together, guys? So all in all, that's how we get the terms in the series. The first 3, and then the last one by substituting the top value in the nth term. Then we need to establish how many terms there are in this entire series. How do we do that? We take the top value, which is 20, which indicates our substitution for the last term. We subtract this value that we have here, which in this case is -2. Then you add 1, guys. As per culture, you add 1. You get 20 minus -2, which is 20, plus 2, plus 1, which is 23. So that means I am calculating, and I'm going to calculate the sum of the first 23 terms. You choose a formula. You can use this one. This one does not need the last term. It just needs n, it needs a, and it needs d. This one, where you have the last term, just needs a, n, and l. Doesn't need d. Both of these should give you the same answer. Ritabile has already said in the comment section the answer is -667. Let us check if that is the case. N is 23. A is 15. D, if I'm using this formula, is going to be T2 minus T1, which is -4. T3 minus T2 also gives me -4. So D is -4. So N is 23, A is 15, D is -4. And if I'm using this formula, my L value, just so you know, is -73. So you must decide which formula you want to use. Guys, I want you guys to confirm for me if you use these values, A, N, and D for this formula. Do you get the same answer if you substituted A and L and N in this formula? Is it really -667, as my dearest, amazing friend Ritabile has said in the comment section? Do we agree? Do we fully and completely agree? And do you guys have any other questions? All right. This is simple and straightforward, guys. How we are able to get the sum of, in this case, the first 23 terms. We find the first 3 terms in the series, substituting this for the first term, and substituting the consecutive values after -2. -1 and 0, so that we can get the first three terms using this formula. There the first three terms are. If you want to know what the last and final term is, you say plus ... and then you write a plus there at the end, you substitute 20 there, you get the last term, so that you know what that is too. Okay, then you want to know what the value of n is, you take the top number minus this bottom number, you add 1, you get n. Then you get a, which is the first term, d, which is the constant difference, l you already have, which is -73. Then you choose which formula to use to find the sum of the first 23 terms. So this one, thank you, Ritabile. Hey, Ritabile, you're very resourceful, you know, very resourceful. Thank you, Ritabile. Gitabile, Ritabile, Gitabile. Yeah, Gitabile. All right, so there, yeah, okay, Ritabile is saying we get -667 for usage of this formula. If we did not use this one, we could if we wanted to use this one. I am just doing both, guys, so that we can be comfortable in knowing that it doesn't matter which one we decide to use. At the end of the day, it will yield the same answers. 15 minus 873. Okay, in this situation, 15 minus 73. Put that in your calculator, should get the same answer. Why am I saying minus 73? It's because a positive times another negative will give me a negative. So I'm not even going to waste my time there. Let's just quickly check the other one. That's 23/2. We put it in brackets there, right? 15 minus 73, close the bracket, we say equal, still truly the same answer. Okay, thank you, Ritabile. I think, yeah, Ritabile. Yeah, right. 12 o'clock just hit. Let me do the last and final one, and then, yeah, I will put this to bed. So guys, I will officially put sequence and series to bed for now. That does not mean that I'm not going to be sometimes revisiting some questions, especially like other questions that maybe I have not done before. I am actually going to continue with the next topic in the next live lesson, which means I'm going to jump into functions. All right, jump into functions, which is the next topic. And we're going to push functions, right? Start off with grade 11, so that we know what we should be knowing, all of us, and then get into the grade 11. Start first with covering the concept. No problems, just the concept. Okay? Just the concept of functions. Then after covering the concept of functions for grade 11, go to grade 12, and then we can start looking at exercise type questions and exam type questions. We'll do that, like I said, the next time. Thank you, Sekhamit. Yes, tomorrow, guys. Tomorrow is the day, you see. But I will occasionally revisit questions on sequence and series, you know. So like maybe in the middle of my lesson, I'll just grab, you know, a question on sequence and series and do it. So we are going to continue to kind of like have a bite every once in a while of sequence and series there and there, so that we do not forget what we did in sequence and series whilst we are doing functions, if that makes sense. And then also I hope you guys will continue to practice your sequence and series. Don't lose, you know, what you've gained. All right, let's do this last one. Find the value of p. Hey, do you see this? Find the value of who? Of p. If p at the top, if idile, okay. Well, thank you so much, Ritabile. No problem, no problem. Screenshot it and practice it, my dear. Thank you so much. It was such a pleasure having you. Thank you, thank you, thank you. Okay. Find the value of p. If p k is equal to 1. 2 into half to the power k is equal to 127 over 64. Okay, it's a nice problem, this one. Okay, I love the way it looks and I like the way we can move with it. Okay, so let's do it, guys. P, so we want that top guy there. Okay, look at my nth term, right? The nth term is what type of series? What is it giving? Arithmetic or geometric? Yes, thank you so much. Geometric indeed. Why do we say geometric? Because this time round, our variable is an exponent. It is not a base, but it is an exponent. When the variable is not a base raised to the power 1, then we say it's geometric. All right? When it's not a variable. Because if it was a variable base and it was to the power 1, then we would say it's linear, just like this one. Variable is a base and the exponent is 1. That means it's linear arithmetic. This one, the variable k is equal to 1, that's our variable. The variable is an exponent, so that means it's geometric. Okay, so that means we can find the first 3 terms of the series then. Do you see? First 3 terms of our series we can find, and we can find the value of what? Of r as well. Okay, yeah. So let's go ahead. First 3 terms. Substitute k is equal to 1 and substitute the subsequent values. You see? Do you see, guys, how easy this is? So we substitute 1. When I say 2 into half to the power 1 plus 2 into half to the power 2 plus 2 into half to the power 3. So that means a is going to be 2 times half, which is 1, plus 2 into half squared, which is 2 times a quarter, which is actually equal to what? A half. So we have a half, 1 plus half, plus 2 into 1 over 8, which is actually 2 over 8, which is a quarter. This is our series. 1 plus half plus a quarter plus dot 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 plus. All right, which means we can go on forever. Okay, so that's the first step. Step number 1, find the terms of the series. Okay, then from there, a is equal to 1. Since it's a geometric series, we can get r. Okay, remember r is t2 divided by t1. So in this case, we have half divided by 1, which is a half. All right, same thing, a quarter divided by a half would be half. So all in all, we have r, we have a, then we need one last thing, n. All right, so step number 2, to get that n, we know we say top minus bottom plus 1. Which top? That top minus bottom. Which bottom? That bottom plus 1. So we're going to say p minus 1 plus 1. That gives us p. Okay. So in my head, I'm like, the sum of p terms. Okay, the sum of p terms. Yeah, but that entire sum, I know it's equal to 127 over 64. So I am going to look at r r is half. This r, guys, is less than 1. And remember, we have a formula that we use when we are calculating what, guys? When we are calculating the values when r is less than 1. So I'm going to choose that formula, and then I'm going to take it from there. So let's do this then. Sn is equal to a into r to the power n minus 1 over r minus 1. Let's just use this formula. Okay, so we know that Sn, or let me say Sp, is going to be equal to 100 and, is it Sp? Yes, is equal to 127 over 64. Wow, guys, it's New Year's Eve, right? Wow, yeah, today is New Year's Eve. That's great. It's crazy. Okay, Sp 127 over 64. All right, so this guy, DT is hilarious. Right, so let's go now and substitute here. All right, in the place of n, we are going to substitute p. In the place of a, we are going to substitute 1. In the place of r, we are going to substitute half. So let's go ahead and do this, guys. 1 into half to the power p minus 1 over half minus 1 is equal to 127 over 64. All right, we want the value of p because they said find the value of p. So p is our obsession, and of course we said top minus bottom plus 1 so that we could establish what the expression for the number, the sum of the number of terms, and it's the sum of p terms. Okay, so that's why we have Sp is equal to 127 over 64. All right, because we established the number of terms whose sum we need to find. The sum of p terms is equal to 127 over 64. Remember, sum of p terms is a, which is 1, r to the power n half to the power p. In the place of n, we will write p minus 1 over half minus 1 is equal to 127 over 64. Okay. Okay, so far are we good, guys? So far is things okay? Then we have half to the power p minus 1 over negative half, because half minus 1 is equal to a negative half, guys. Do you see that? Half minus 1 is equal to negative 1. Hope that is clear as well to all of us. Then this needs to go, the division of negative half needs to bounce. So we are going to multiply at the top by negative half, so that this negative half and that negative half cancel out. But a negative divided by negative is positive. But what we do on the left, we do where, guys? On the right. Okay, so we multiply by negative half on the right as well. And when we do that, okay, we are going to be left with half to the power p minus 1. Grab your calculator, you multiply 127 over 67. I wrote 67. Oh, sorry, my bad. Thank you for that correction, John. It's a bad error, right? Thank you, guys. Thank you. Hopefully, I love the fact that you guys are seeing my errors. It means you are vigilant. You are aware of what's happening. Please make it a point that we exercise that same alertness and awareness as we do problems ourselves. Otherwise, thank you so much. I really love that. From the Queen herself, Baby Immaculate. 127 over 64. We multiply by negative a half. We get negative 127 over 128. All right, when we multiply by negative half. Okay, then we transpose this negative 1. So half to the power p is equal to negative 127 over 128 plus 1. So we are going to add 1. We get a positive 1 over 128. Okay, so far so good. Then (128) is equal to shift fact. I want to see in exponential form, what do we get for 128? We get 1 over 2 to the power 7, which in all honesty we can write as 1 over 2 to the power p is equal to 1 over 2. Now we can take out the exponent 7, because when the exponent 7 is applied to 1, it still leaves me with 1. 1 to the power 7 is 1. Any base 1 raised to any exponent will always give me 1. I apply that same exponent to the denominator, it gives me back that 2 to the power 7, which is the 128 that was in the denominator. What do you see, guys? Bases are the same. Half, half. Bases are the same. So what do we do to our exponents when the bases are the same? What will be the value of p? Because remember, we were actually trying to find the value of p by doing this question to begin with. Okay. So I hope you guys see what I've done step by step here. So therefore, the value of p, thank you so much, Queen. P is equal to 7. Right? Thank you so much. Really appreciate that response there. Okay. Yeah, Baby Immaculate is doing the things there in the comment section. So P is equal to 7. Say Khamid, thank you so much for 4 of those, you awesomes. Really appreciate it. So P is equal to 7, guys. Very well put, and simply put, that is the value of P. So if you can see, the skills required from the formula substitution to the end all have to do with algebra and simplification of exponents. When did my beloved grade 12, that is you, do exponents? In grade 11. It was in term 1. You did exponents and surds. So your skill level to solve exponential equations should be just good. You know, there should be no question about you getting to the answer. Algebra, applying your inverse operations, applying your, your algebraic acumen needs to be as good. So all in all, this is how we do this particular problem. Okay. Yeah, guys. I think that's pretty much it for today. Thank you so much for joining in. I would please implore all of you and encourage you to continue practicing, continue leveling up, and improving your exponents, sequence and series, algebraic equations game. Right. Ngoma, it will still be 9. All right. I will definitely leave you guys, so that you can be able to say Happy New Year without me. I don't want you to be saying Happy New Year whilst you're still in the live. So maybe we'll keep it at just an hour from 9 until 10. Or let's say 9 until 10:30 tomorrow, so that you guys can say Happy New Year, not here in the live. You can say Happy New Year somewhere else. Happy New Year under different conditions. Remember, guys, that the lessons that I do here, I do upload them raw as you find them onto my YouTube channel, so you can rewatch sessions not seen here. That you may have anything that you may have missed. You check it out there. So yeah, we'll start functions tomorrow, sort of like recap on grade 11, the concepts in grade 11, which is very important. Functions, guys, are easy. Your functions game needs to be top notch as well. Your grade 11, grade 10 functions game needs to be top notch, top level. Grade 12 is really straightforward, okay? Grade 12 is straightforward because in grade 12 you are just dealing with inverse functions, okay? And really and truly, guys, you're talking about your exponential function as an inverse. You're talking about your straight line function as an inverse, and then you're looking at your parabola, how you can express a parabola as an inverse function only if you restrict the domain of the function for your parabola. And that's pretty much about it when it comes to functions. Everything else that is important and crucial in functions is coming from grade 11 and 10. Which is why I'm saying you need to have your A game on for all concepts for functions, so that functions can start being one of those topics where you are able to easily get your 100% in, right? And guys, grade 12s of 2025 were given the hard bargain, if you ask me, when it comes to functions, because the questions that they were asked, a corner. Yeah. And you guys are the last cohort that is going to actually be tested under the same exam guideline that has been utilized for the past, I guess you could say, since 2014 or 2021, because the exam guideline is going to go under review now in the next year. And I think in 2027, the grade 12 cohort group is going to write their metric exam using a completely different exam guideline, which would mean that there's going to be new things featuring, or let me say maybe not new things per se, but definitely the focus of exams now will be different. What they are wanting to do is to depart from examining you as per previous groups have been examined, meaning you guys have an idea of the structure of questions that are going to be asked. They want to depart from that because they want to start testing your, they want to start testing to see if you can apply mathematics, in different scenarios that are not common, right? As the grade 12 cohort group, for instance, of 2025 actually experienced. No, Sekhametse, I doubt it if they'll add matrices, but if they do, then I guess it will be that committee that will actually review the things that will see if that will be necessary. I have no idea. What I do know is that the exam guidelines are changing for 2027. You guys are still going to use the exam guidelines that have been for the past couple of years, but the 2027 group of grade 12s is going to use a completely, I guess, a reviewed exam guideline moving forward. Okay guys, thank you so much. Have a good night. Please take care of yourselves, and practice so that we can win with the mathematics. just more problems I would have obviously done, because there's so much more, guys. I mean, really and truly. But similar type of questions, just so that we get that practice in. So you do it, make it a point that you go past papers, guys. We have from 2014 end of year exams up until 2025 now, the most recent. So imagine if you could practice all the questions that have been ever asked for your end of year exam since 2014. You do the 2014 November paper, you do the 2015 November paper, you do the 2016 November paper, you do basically sequence and series for all of those papers. At least you will be really covering a lot of ground if you can just do that up until 2025. Then when you do the next topic, you do the same thing. Okay, you go through the 2014 paper, 2015, 2016 up until 2025. That will really boost your confidence. I can promise you that. You will really be ahead of the game in so many ways by doing that. So yeah, there's lots of questions that are available to be done. Yeah, that you can familiarize yourself. Okay, guys, thank you. Let's see each other again tomorrow. Right? Thank you. Bye. Baby Immaculate, I have no idea which app is best for practices, because honestly there are so many apps that are there. But yeah, people use different apps. I honestly like, yeah, there's many apps. As long as you can find an app that can actually provide like the actual past papers from 2014 up until recently 2025, and the memos are available for you to actually check out the minute you do a problem. Okay, bye guys, bye. Thank you again for the gifts and everything. Thank you for participating, and thank you for being awesome. Actually, let me just do what I usually always do. So Hamid, thank you so much. You've contributed quite a bit of coins, diamonds, if you want to call it that. Thank you, Hamid. Thank you again. Thank you so much. I really appreciate you, dear sister, mother, everything. I really appreciate your valued contribution, as well as just the gifts all the time. Really encouraging. Thanks a ton. Slash, thank you, Ayola Suka. Oh, Ayola, you were here actually. Hello, Ayola. Zala knowledge, it's always my brother. Baby Immaculate, amazing. Don't be Faith, don't be girly. It's nice having you. Nosi, awesome. Oh, we have the fan of Matters a game here as well. Oh, awesome, man. Army. Mpumza Nom. I've got a fan. I didn't know that. Nom. Oh, Nom. Good seeing you. Kamo Khelo Mapanga. It's good seeing you, buddy. DK10. I don't know if it's Togieda or Dogieda or what. Might be saying it wrong. Kenny Brew, Adise, Belede, King Charles, Kaboyelo. We've got Breaky, SK Za. Verena, Sia, we've got Sepi Sotobahale, we've got Roniwa, we've got Stanmore, Bekanwane, Kenny, Bright Shake, Tando, Letaba Mkhotwane, Tulisile Lubuzo, we've got Mediclinic Cape Town, user 493124, I'd say your entire word number, but yeah, I'm on the 021, Abu Bakar Hanif Edits. I go by Joe, you do. Les Showstopper, we got Scarly, we got Dusty SA, King Ghost, Tugi, Ceci, Date, Apile Sibia, we got Ndondo, we got Koboka, we got Isaac Tove, we got Yanga, Chwe, Mbeni, Kumo, and W. Wase. Guys, thank you to all of you. You were great, amazing. Have a great one. And thank you again for the gifts. Thank you. It means the world. Thank you. Have a great night, and see you again tomorrow, 9 p.m. Same time, same place, same condition. YouTube handle linked in my bio, good sir, or good ma'am. link in my bio. Just go to my bio, you'll see the link. Click on the link and it will send you to my YouTube channel. It's at Maths is a Game 5 to 7. That's basically the link. It's Maths is a Game is together. It's all together, man. And then 5 to 7. It's all together. Like you 5, a dash, and a 7. Or is it a hyphen? Yeah. At Maths is a Game 5 to 7.